factor theorem? Factor theorem is just one step more of the remainder theorem. It's saying, hey, if the remainder is 0, your binomial must be a factor. It must be a multiplication part if you got 0 when you divided for the remainder. If you divide a polynomial by x minus a and the remainder is 0, then that binomial is a factor because you divided and got no remainder. Just like 12 divided by 2, I get 6 with no remainder, it's a factor. If P of A equals 0, then what we know is that x minus a is a factor, multiplication part, until we remember what factor means, of P of x, the polynomial. Okay, so let's look at some Regents questions they could ask. Now, this is just the remainder theorem, but when you did the remainder theorem, you got 0. No remainder. If f of x is a polynomial function, and I know that when I put a 3 in, I get a 0, which is a remainder, what must be true? And I want the answer to be something is a factor of f. Okay, in this particular example, what would be the factor? If I put a positive 3 in, what would the factor be? But it's not negative 3, it's a binomial. X minus 3, that binomial is a factor. So if I put a positive 3 in, I know the 2-term binomial x minus 3 is a factor of f of x. Okay, let's look at the next question. How can you tell whether x plus 2 is a factor of that polynomial? Well, that means when you divide, you get no remainder. That's a definition of a factor. So what would I put into G to tell that? What would I put in? Negative 2. I would find G of negative 2. If I wanted to know whether x plus 2 is a factor, I would put a negative 2 in. So go ahead and do it and tell me whether it's a factor or not. And that would be the work you would have to show. Negative 2 to the 3rd power plus 2 times negative 2 to the 2nd power minus 2 times negative 2 minus 4. If I plug in a negative 2 into the function and I get 0, number one, I can tell you there's no remainder. But more importantly, I can tell you, so x plus 2 is a factor of g of x. So the factor theorem is just a special case of the remainder theorem, saying if the remainder is 0, now there's something special about your binomial. Now, usually the questions are super straightforward, but this is how they up the difficulty of a question. This next example. So in the next example, they told you something. They told you that x minus 4 is a factor. Like, I don't have to guess whether it's a factor. They told me x minus 4 is a factor. They told me about this polynomial, but the problem is this polynomial has a missing coefficient. I don't know what goes in front of the x. Okay, but if x minus 4 is a factor, we know that h of positive 4 has to equal what? What does it have to equal? 0. So we know that when we put 4 in for x, our polynomial will be equal to 0. That's what factor theorem says. So that's what I'm going to do to make an equation where I can solve for b. I'm going to put 4 in for x. And I know, because it's a factor, that when I put it in, that polynomial equals 0. So now I made an equation, and it only has one variable in it. I can solve this equation for b. First, I'm going to try to simplify it. This is 64 minus 16 minus 4b minus 12 equals 0. And then I'm going to combine these like constant terms together. And what do I get? Thirty-six minus 4b equals 0. How would you solve this equation?
Add the 4b over and then divide 36 by 4.
So what we found out, that is, if x minus 4 is a factor, then the number in front of the x is a 9. Okay, that's what we figured out. That's like upping the difficulty level when they do that to you. But they had to tell you that x minus 4 is a factor so that you could make the equation. Okay, last problem. And then we're going to do an activity on our iPads. This time, instead of writing out what the polynomial is worth, they just gave you the graph of the polynomial. Okay? But the graph is the same. You can figure out what x value gives you what y value, like by looking at a point. So let's just look for a minute before we answer these questions. Can you guys tell me, if I put 0 into the polynomial function, what would I get? Looking at the graph. Yeah, that is this point right here. The x part is 0 and the y part is 0. So if I put in an x, out comes a 0. Can you tell me what you would get if you put 1 into the function? Thank you. What would come out? Here's the point. The y value is -2. So if I put a 1 in the function, a -2 comes out. Okay, we'll do one more. What if I put a -2 into my function? What would be the y value that comes out? Yep, up here it's that point. When the x was -2, the y value is 4. So that means when you put a -2 in the function, a 4 comes out. So that's how we're reading this function. We don't know the actual polynomial, but we know how to find out what you get if you put numbers in. So I, of course, can't use synthetic division on this one because I don't know what the polynomial is. And they want to know, what is the remainder if I divide the function by x minus 1? So what would I have to put into the polynomial to figure out the remainder? A +1. And that will tell me the remainder. Well, that's one we actually looked up. What is p of 1? It's right here. P of 1 is -2. So remainder when dividing by x minus 1 is -2. this is kind of a mess here. I'm just fixing up what that looks like. P of 1. Now, it says, tell me 3 factors, 3 binomials factors of this function. So I need to find all the x values that I could put into the function, and I would get 0. Because those will be where the factors are, because all of those would give me binomials that have remainders of 0. Can you guys find the 3 x values on this function where y is 0? When does that happen? Well, we said it happened here at the point 0, 0. What other points does it happen at? -4 at 0. And what's the other point? Okay. So I know if I put in a -4 into the function, I get 0. If I put 0 into the function, I get 0. And if I put +3 into the function, I get 0. So there's 3 times where I would have no remainder. So what would the factors be? Because remember, the factors are binomials. They have 2 parts, an x and a number. What would the factors be?
X plus 4, x plus 0.
It could be x plus 0 or x minus 0. This is the only time, well, it's probably just x, right? Because if you add 0 or subtract 0, you just get x
X minus 3.
and x minus 3. So here's our factors. Remember, the numbers in the factors have the opposite number that's in the function. Okay, I'm going to see if you guys figured it out by doing a Desmos activity. So what I need you guys to do is go to desmos.com, and I'm going to give you a code to put in.